So we finally reached the last section of this chapter, synthesis strategies. So here we're asked to put all the reactions that we've learned together and make new compounds. So we're asked to propose an efficient synthesis for compound A to make let's do compound A here to make compound B. And the first thing you'll notice is that compound A has a carbon here and a carbon here and then a cyclohexane ring. Carbon B has a carbon here, a carbon here, a carbon here. So we're going to have to add another carbon. And the only way we know how to add a carbon is to add it to a terminal alkyne. So we're going to take our alkene and convert it to an alkyne, and then we'll alkylate it and then convert it back into an alkene. So that's our general, what we're planning to do. So what we'll do is first thing we'll need to do is add bromine to both of the carbons here and here, and then we can make a triple bond. So let's make our cyclohexane. After we have our triple bond, we'll be able to add our methyl group to it. And then we'll be able to reduce. And we'll have. I'm sorry, that's not drawn very well. Let me do that a little better. Okay, so we need to have the reagents in here. So this one's pretty easy. It's going to be bromine, and we'll do this in a carbon tetrachloride environment. We'll reduce with a sodium azide, with sodium nitride. We'll add our methyl group with methyl iodide. And then when we reduce this triple bond to a double bond, we want a trans. We want it to be trans, so we'll need to use sodium dissolved in ammonia. Okay, so I've got 6 of these to do. And I'll try and walk you through my thinking each time. So here are the first 3. You might want to try these on your own first. So we start with A, and we'll notice that this is a 4-carbon compound, but this is a 6-carbon compound. So we're going to need to add 2 carbons. And so we're going to have to make a triple bond, make an alkyne, and then reduce it to make a cis. To make a cis double bond. See how we're going to do that. Well, first we'll add bromine, and we'll need to do this with a carbon tetrachloride environment. And here's our bromine. Once we have that set up, we can do our sodium nitride, and we do that in a liquid ammonia environment. That's supposed to be an L in the O. And then we finish with water. This is a two-step reaction here. And that will give us a triple bond terminal. And we know we've got 1, 2, 3, 4 carbons, and we have 1, 2, 3, 4 carbons. I know I seem a little obsessed about that, but it's really easy to get your number of carbons messed up. So then we treat with sodium nitride again in a liquid ammonia, and this time we treat with an ethyl iodide because we need to add 2 carbons. This will be a 2-carbon unit, and that will give us just for clarity, let's do the ethyl in red, and we'll show this one as being the one that we added. Okay, let's go back, and now we need to reduce this. We need it to be cis, and we don't want to reduce it all the way to an alkane. We want to keep the double bond, so we'll use a Lindar's catalyst and some hydrogen, and we will get what we're looking for. So if we look at B here, it's an aldehyde. And we know we make aldehydes by using the borohydride oxidation of a terminal alkene. So, hydride of terminal, that's my abbreviation for it. So we're going to need to make this a terminal alkane. We've got 1, 2, 3, 4 carbons. Our product has 1, 2, 3, 4 carbons, so we don't need to add any carbons to anything. So here's B. We're going to start off, we're going to treat with bromine and get we can then treat with our sodium nitride and water. So this is a 2-step reaction, and we'll get we then want to treat with our sterically hindered boron hydride, followed by hydrogen peroxide and sodium hydroxide. And this will give us, remember this puts an OH on the less substituted carbon. So we'll get a double bond, we'll get an OH here, and remember we've got 1, 2, 3, 4 carbons. This is an enol, so this is not going to be stable, we're not going to be able to isolate it. But what will happen is we'll get our 1, 2, 3, 4 carbon. That will end up our aldehyde. Oh, I'm sorry. I'm moving stuff around. I didn't mean to move. Okay. So let's do C right here. We need to get an alcohol on this carbon right here. We have 4 carbons in our reactants and 4 carbons in our product, so we don't have to add any carbons. What we're going to want to do is reduce this triple bond to a double bond, and we use a Lindar's catalyst. I think I'm misspelling that. I think there's an L in there. We'll get and then we can do an acid catalyzation with dilute sulfuric acid. So we'll get a Markovnikov's addition. So it'll be at this carbon right here. We'll get our hydroxy. You see here that D is very similar. We've got 4 carbons, 1, 2, 3, 4, and 1, 2, 3, 4. So we don't need to add any carbons. We just need to add this hydroxy group onto the terminal carbon. So if we reduce with Lindar's catalyst, and hydrogen, of course, we'll end up with this. And this time we want an anti-Markovnikov's addition. And so we will use the borohydride. Followed by hydrogen peroxide and sodium hydroxide to get the anti-Markovnikov, to get it to come to this position.